What's up, everyone? Hope everyone's having a good day. How's it going, Wasim? Good to see you again. And it looks like the chat is not working. It's like every other stream. That's so annoying. I'm going to just turn it off, I guess. And I'll just have to read the comments out loud. Yeah, today's going to be fun. We're going to be learning all about recursion from the Elixir Getting Started guide. And recursion is basically one of the most important things that you can understand for Elixir, because if you're coming from a mutable language, you use like for loops and things, and you can change like your counter and a dictionary or a list or an array, whatever you're passing in, and you can mutate the object within one loop. But with a functional language like Elixir, you can't do that. So you're actually recursively calling the same function over and over, passing in a new state, essentially. So I'm excited to go through the docs. It'll be good. It'll be a lot of fun. And I'm excited. Let's jump right in. Hey, Sasha, good to see you, man. All right. I have to find my button. There we go. All right, let's go ahead and pull up Firefox. And if you guys haven't yet, you can click on this banner at elixirmentor.com and get my really cool cheat sheet. And if you have done it, let me know what you think of it. And if it's missing anything, let me know, because I will definitely add to it. elixirlang.org. All right, and then guides, and today is recursion. All right, so recursion. Elixir does not provide loop constructs. Instead, we leverage recursion and high-level functions for working with collections. This chapter will explore the former. And it's good to know, like, they're talking about high-level functions like reduce and map in the Enum module. But behind the scenes, those are using recursion as well. So this is a good base, because I believe the next chapter is enumerables and streams. So we're going to probably be touching on that in the next section of this guide. So loops through recursion. Due to immutability, loops in Elixir, as in any functional programming language, are written differently from imperative languages. For example, in an imperative language like C, one would write a for loop. So where they're setting I to 0, and then as long as I is less than the length of the array, this code will be executed. And then when it's done being executed, I gets incremented by 1. And that happens until it reaches the length of the array. And in this case, you can also see they're changing the values in the array. And they can do that because it's a mutable language. But in Elixir, you can't do that. In the example above, we are mutating both the array and the variable I. Yeah. However, data structures in Elixir are immutable. For this reason, functional languages rely on recursion. A function is called recursively until a condition is reached that stops the recursive action from continuing. No data is mutated in this process. So consider the example below. All right, I am going to, let's see, I'm going to pull up the terminal. Oop, wrong window. I'll make this a little bigger for us. And what I'll do is I'll cd to the desktop, and we'll create an Elixir script file. So we'll say touch, and we'll call this recursive.exs. Okay, cool. And then let's see here. I guess what I should do is probably just open this with VS Code. Open, how do I open just a file? Open. You can tell I do this a lot. It's not often you just write one file outside of a project, right? There we go. All right, so we're gonna write some code, some recursive functions. So if we create a module, and it's just gonna be def module recursion, and then don't do that. And then we'll just have our do and end block. And with this, so recursive functions always need like a base condition or like a condition that ends the recursion. So what we're going to do here is we're going to write two functions, and with recursion, you leverage pattern matching. So we're going to go ahead and copy this example here, and it's called print multiple times. So we're going to create a function called print multiple times, and this function takes a message and an n argument, and the n is the number of times we want the message to print. And then we have a guard here. As long as n is greater than 0, this function will be called. And then we're just going to IO puts our message. And now with recursion, you have to call the function, you call the function from within the function. So it keeps calling itself, okay? So now we're going to call the function we just created, print multiple times, and we're going to pass our message back in. And now n, whatever that value is, let's say in our case, we're going to be passing in 3. We want it to be 2. So we have to take the current value and subtract it by 1. Otherwise, it would be an infinite loop, and that wouldn't be good for us. All right, and then, so we need a case for when n hits 0 because we want our recursive action to stop. So we write our function again. We have to name it the same exact thing. So print multiple times. And this time we don't care about the message, and we're pattern matching. So when n equals 0, this function is going to be called. And if you notice, when n is greater than 0, this function would be called, right? So here we're just going to return the atom OK, and that will end our recursive callback. So if we save this, and we can go and pull up our terminal, and I believe you can run the IEX script to a file if we just do IEX and then we call our file or our script here. Yeah, sweet. Okay, so now we can say recursion.print multiple times, and we can pass in our message, which is a string, and how many times do we want it to do the IO puts. We're going to do 3. So when I hit enter here, we should see hello, hello, hello 3 times, and then we should hit our base condition, or our basically the condition that breaks our recursive call, and we should get our OK atom back. And there we go. We got hello, 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 and then our OK atom. So it looped through 3 times and then ended the recursive call. Pretty cool. All right, so similar to case, a function may have many clauses. A particular clause is executed when the arguments passed to the function match the clause's argument patterns, and its guards evaluate to true. So like you saw, when as long as we had a message and a variable n, and then our guard, as long as n was greater than 0, this was true, and it would execute the code in this function. And when this guard failed, it would go on to the next case, and as long as n was 0, it would call this one. All right, pretty cool. So when print multiple times arity2 is initially called, in the example above, the argument n is equal to 3. So the first clause has a guard which says use this definition if and only if n is more than 0. Since this case, it prints out the message and then calls itself, passing n minus 1, which is 2, as the second argument. Now we execute the same function again, starting from the first clause. Given the second argument n is still more than 0, we print the message and call ourselves once more. Now with the second argument set to 1, then we print the message one last time and call print multiple times, pass our message hello in, and now n is 0. Starting from the top once again, When the second argument is 0, the guard n greater than 0 evaluates to false, and the first function clause won't execute. Elixir then proceeds to try the next function clause, which explicitly matches on the case where n is 0. This clause, also known as the termination clause, that was the word I was looking for, not my base, whatever I said. The termination clause, so it ignores the message argument by assigning it to the underscore message variable and returns the atom OK. All right, so finally, if you pass an argument that does not match any clause, Elixir will raise a function clause error. All right, so if we pass in what they're doing here, because we're only doing everything 0 and above, we don't have anything for negatives. So what happens if we do pass in a -1? We get our function clause error because there's no case that matches what we just passed in. So we get our function clause error. And, you know, in the real world, you would want to cover this, right? You would want a fall through and you would handle this accordingly. All right. Okay, so now reduce and map algorithms. So let's now see how we can use the power of recursion to sum a list of numbers. Okay, this is cool, right? So let's go back to our little file. You know, maybe I should make a new file. No, you know what? Let's just go to VS Code. We'll make a new module here. We'll still call it recursion, the file name, but we'll say def module math do. And why does it keep doing that? Okay. See, the problem with having all your what would you call that? The language server and everything. When you try to set it up for Phoenix Live View to handle, you know, the HTML, the Heeks templates and stuff in a live view file, you got to watch your autocompletes because it always wants to do the HTML autocompletes over the Elixir autocompletes. And maybe it's just because I don't have my environment set up right. I don't know. It's possible. I'm not very good at that. I usually get it working and then I'm happy. Hey, how's it going, Mike? Good to see you, man. And I apologize. The chat isn't working again today. And oh, it is working. Sweet. It wasn't working at the beginning. Look at that. It's like magic. So there it is. All right. So back to creating our math module. So we're going to create a function called sumList. So def sum underscore list. And what we're doing here is we're adding all the integers in a list together. And similar to using like enum.reduce, we're going to have an accumulator to keep track of the sum. So we're passing in a list. So we care about the head and the tail. And if you don't remember, head is the first value of a list and tail is the remaining list. So that the tail can be multiple items still and it will still be a list. And then head is always a single item. And then we're going to have our accumulator. And our accumulator is going to be the sum of our values that we're keeping track of. So let's say we have a list of 1, 2, 3, and we're only through the first value of 1. Our accumulator would be 1, and then we would recursively call our function again, and our accumulator would be 1 instead of 0 when we start it with our initial value of 0. All right, so inside of this, now we just want to recursively call this function again. So sum list, and here we want to, so the first variable has to be a list, but we don't want to use the head. So we only want to pass the tail in. So this is going to be our list minus the first value. Pretty cool, right? And we want to take the first value and add it to our accumulator. So we can say head plus accumulator. So look at that. So if our accumulator is 0 and our head is 1, now our accumulator value is going to be 1 when we call our function again. I think it's pretty nifty. I remember when I first learned recursion, it hurt my brain. And then when you finally get it, so like if you don't get this right now, just rewatch this video or go through the documentation or read it on your own and follow along. It's important to write your own code, but when it clicks, it'll click and you're going to love it. So now we need our termination clause, right? And it needs to be called the same thing. So sum list. And we want this to match when we have an empty list. So when we have no more items left in our list, and we can do that with just an opening and closing square bracket. And then we want to pass in our accumulator again, and then do end. And then all we're going to do here is when our list is empty, that means we have gone through all the items in our list. We want to return our accumulator. All right, pretty cool. So now if we go back to our IX shell, clear. I think I can recompile, saying recompile. No, is it compile? Compile. Why? I hate when I go blank, and I always go blank when I'm live. Oh, maybe I just have to do recursive.exs in a string. Yeah, cool. So now if we call our math.sumList, we can pass in a list. We're going to pass in 1, 2, 3, close the square brackets, and we're going to start our accumulator at 0. Okay, that's important because if we started at a different value, it would be added to. So if we add all these values together, 1 plus 2 is 3. 3 plus 3 is 6. We should get 6 back. And there we go. We got 6 back. That's pretty cool, I think. So we invoke SumList with the list with values 1, 2, and 3, and the initial value is 0 as arguments. We will try each clause until we find one that matches according to the pattern matching rules. In this case, the list matches against the head and tail, which binds head to 1 and tail to 2 and 3. An accumulator is set to 0. Then we add the head of the list to the accumulator, so head plus accumulator, and call SumList again, recursively passing the tail of the list as its first argument. The tail will once again match our head and tail list until the list is empty as seen below. So yeah, this is pretty cool. This is what's happening. We pass in our full list of 1, 2, and 3 with the value 0. And once 1 is taken off, because we take the head away, we add 1 to 0, and then the tail gets passed in as 2 and 3. And then we take 2 off and add 2 to 1, which we get 3. And then the tail is just 3. And then we finally pass in 3, and the head is 3 and the tail is nothing. And then so we pass in our 3 plus 3, and then when the tail is nothing, it will just return the accumulator as the fourth. So pretty cool. So when the list is empty, it will match the final clause, which returns the final result of 6. So the process of taking a list and reducing it down to one value is known as a reduce algorithm and is central to functional programming. So the similar thing, if you use enum.reduce, it's the same thing. You're iterating through a list and you have an accumulator. And then if you use like enum.map, you're just iterating through the list. So when you see reduce, it usually means you're going to be taking a list of values and it only ends up returning one value at the end. And it normally has like some sort of accumulator where it can track its progress, or state, I guess would be a better word to say. How's it going, Aldrin? It's good to see you. Thanks for being here, man. All right, so, okay, I just forgot where I was. The process of taking a list and reducing it down to one value is known. Okay, what if we instead want to double all the values in our list? All right, so why don't we do that? Let's open up our VS Code file again. So if we were to now, we're going to just write some new functions in math. We're going to call it double underscore each. And we're still going to do our list, and we're pattern matching. So as long as the list has values, we're pattern matching the head and the tail. All right. And so as long as we have values, then it's going to execute this code. And what we're going to do here is we want to double every value in the list. So we need to take our head and multiply it by 2. And then we're going to prepend the head to the list. And our list is, so then what we're prepending to is the tail. Like this one is kind of getting trippy, right? This is like Inception stuff. So we're going to recursively call our double each on the prepended piece. All right. So, and pass in our tail. So I feel like I'm not set up to draw, but essentially what's happening is we're taking our head, we're doubling it, and then we're prepending it to the tail. And then the tail would be, in like our case, if the head is 1 and we still have 2 and 3, then the tail is 2 and 3 here. And we just prepended the doubled value. And then it keeps calling until it hits the terminator function or the terminator clause, which is going to be double each, and we're going to match it to an empty list. And then what happens here is we're just going to return an empty list. And let's go ahead and run this, and it will return a list every time this is called. So I think we'll see it. Let's see. Let's recompile. All right, I'm going to clear this so we can see. So now if we call math.double each and we pass in our list of 1, 2, and 3, we should get 2, 4, and 6 back, right? There we go. So that's pretty cool. And yeah, maybe the documentation explains this better. It's hard for me to explain this one because I feel like, I don't know, my brain doesn't really, this is what I was talking about when I first started learning. This is like where the inception kicks in, right? So here we have used recursion to traverse a list, doubling each element and returning a new list. The process of taking a list and mapping over it's known as a map algorithm. Okay, I made a library. Recursion and tail call optimization are an important part of Elixir and are commonly used to create loops. However, when programming in Elixir, you will rarely use recursion as above to manipulate lists. The Enum module, which is where you're going to see in the next chapter, already provides many conveniences of working with lists. For instance, the examples above could be written as the enum reduce, where you have an accumulator. I'll write these out. And then you have map, where we're just doubling every value. So what's important to know, though, is reduce and map are leveraging recursion in the background, but it's also good to kind of understand recursion so you know how it works. So let's go ahead and we'll run through these examples since they're here, and we're going to learn all about them in the next we'll do it in the IEX show, and we're going to learn about them in the next section. So that'll be cool. So with reduce, this is where we have the accumulator, right? So reducing takes multiple values like a list or a collection and does something to that collection and will return a single value. And that's where the name reduce comes in, which usually means there's an accumulator to track the state. So if we have reduce, we're going to pass in our same list, 1, 2, 3 in square brackets, and our accumulator starts at 0, and then we pass an anonymous function here, and x is the value of the list we're on. So it'll be 1, and then it'll be 2, and then it'll be 3. And then we have our accumulator as the 2 arguments we're passing into our anonymous function here. And then what we're doing here is we're just adding x to our accumulator and then end. So this function is the same thing as what we did right here. So these two functions for in our math, that is what the reduce function does. So when I hit enter, we get 6 back. Cool. And then enum.map, we pass in 1, 2, and 3 again in a list. And then this takes an anonymous function as well with one argument being passed in, which is x, and then we're just doubling it. So this is our double values, and we're just going to say x times 2, and then we end our anonymous function, close those parentheses, and hit enter, and we get 2, 4, and 6 back. So writing this enum.map is the same thing as what we did here. Obviously, they probably cover a lot, like all the cases, right? Because we're only set up to handle integers and floats. If you passed in something else, it wouldn't work very well. And I mean, obviously in map, if we did and try to multiply a string by 2, it would throw an error. And then next, we're closing this off with using these same functions with the capture syntax. So we can take our reduce function here, and we can get rid of this whole anonymous function using the capture syntax, which is pretty cool. And what this capture syntax is, you can pass in either it's the ampersand, and you can pass in the function that you want to do with the arity, and it automatically knows what it's passing in. It automatically knows it's adding, the value of the list to the accumulator. So the ampersand here, that's the capture syntax. And then we want to use the plus function, arity2. All right, so doing this is the same thing as doing this. So that reduce function is the same thing as this function, and we get 6 back. And then we can also do it, so if we do the map where we're multiplying by 2, let's delete this anonymous function. You can also do it with the capture operator like this, and then inside of parentheses, like this is when you wanted to like control things a little more. So up here, we're saying just use plus arity2 function, and it automatically knows what values that it's passing in. It's passing in x, and the accumulator, right? But if you wanted a little more control, you can say, okay, I want the first variable, which you can use the ampersand 1, and then I want to multiply that by 2. And this works the same way, but it's just a different way to do it. So if you wanted to do something a little more manual, you could do it this way, and then we still get our double. But I believe if we wanted to still do this the more simplified way, we could say, I want this to use the multiplier function that is arity2. Oh, that might not be a function. Dun, 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 dun. Let's see. Can I do that? H. Does anyone know what module this is in? H. Is it math? No. Erlang? It doesn't matter. Trying new things while live. So that's pretty cool. And so we'll be taking a deeper look at the enumerable module. And while we're at it, its lazy counterpart, stream. So that'll be cool. That'll be the next live stream. And let's see, today is Thursday. So our next live stream will be Tuesday, I believe. So that was fun. Thanks so much, guys, for joining in. How's it going, Juan? Sure, man. Why don't you share it in my Discord channel, and I'll take a look when I can. And thank you. Thank you for liking my videos. All right, guys. Well, thank you so much for joining, and I will see you in the next live stream.
Enjoying the video? Show some love with a like and hit subscribe to stay updated. To support me and keep the content free, click join for memberships or pick up a course at elixirmentor.com and get free access to my private community. Let's jump back in.